My name is Dan Kittredge. I'm from the States. I grew up on an organic farm. My parents were leaders in the organic movement starting in the 1980s, helped write some of the first organic standards in the US. So I come from a background both as a small farmer, but as well in the food movement effectively for most of my life. I worked in the developing world. I worked in Central America. I worked in India, spent some time in Siberia when I was younger, experiencing what life was like for farmers around the world. When I got married, and is everybody able to hear me? Yes. Okay, good. All right. When I got married and had found no better way, I thought, to raise a family than on the land and with a simple life as I had been raised, I set about trying to be a farmer myself. At that point, I realized that, like a lot of farmers, I was not a very good one in that I wasn't able to make a living. And that, to a large degree, had to do with the fact that my plants were not healthy, as defined by being eaten alive by a flesh-eating fungus, which most of us, I think, would agree that if one of our children was being eaten alive by a flesh-eating fungus, or perhaps a dog, we'd say something was wrong with that child or that dog. But when it happened to our squash or our tomatoes every year, we sort of normalized it. Similar with larvae, we had larvae eating our potato plants alive every year, and that was just normal for us. But actually, being eaten alive by larvae is a sign of poor health. I don't think we've necessarily normalized that in the farming context, but actually it does correlate brilliantly with a number of factors. And so that was a process I started going through almost 20 years ago now, realizing that my struggles being economically viable as a farmer had to do with the fact that my plants weren't healthy. And then so began to look outside of the organic rubric to understand insights from agroecology and permaculture and biodynamics, biochemistry, microbiology, quantum dynamics, and through some fairly small shifts in practice, got to a point where pest pressure was gone, diseases were gone, yields were up, cost of production was down, economic viability was much higher, and I was making my living farming, working 20 hours a week. That came through that process of learning and broadening my perspective, and one of the things that I heard about in that process of learning was a thing called BRICS. The BRICS refractometer is something that's been around.
So, sorry, Dan, 1 second. We're just opening your presentation as well. So you can keep talking, but we just don't see you for a second, but then you know.
Okay. It would be wonderful. I'm glad you got it over there. And maybe I'll be able to see what it is which slides up. We'll figure that out, I guess, in a minute. Yeah, at any rate, I learned about this thing called BRICS, which was a very simple form of analysis that's been around for almost 200 years. It uses a thing called a refractometer. I've got a refractometer right here. This is something I think this cost, I think it was 12 pounds, UK pounds this cost. So it's a very simple mode of assessment. You squish the leaf, you squish the carrot, you squish the potato, and you can get through a drop of juice, looking through a refractometer, and empirical assessment, which correlates with vigor, vitality, pest and disease resistance, flavor, aroma, shelf life, soil health. And there was a deeper conversation there, which basically was that just because you're organic doesn't mean you're highly nutritious. There's actually a variation which can be discerned empirically. And that was a powerful insight for me, causing me to ask my elders then at that point in time, what's the word for this thing, this variation in nutrient levels in food? And as there wasn't one, we set about creating one. And that term nutrient density is one that we created about 17 years ago now to engage this deeper conversation. Are my slides up?
Not yet, but almost. We have it open. I'm just going to quickly see if I can... it's this one, right?
I'll keep talking.
Yeah, but we just don't have it. Sorry, Dan, just a second. It is this one.
Yeah.
Yeah, no, it wasn't. Huh? Was it on here? Oh, it's open here. Okay. Yeah, sorry.
I'll just keep talking.
Yeah. 1 second, we're almost there. And then here. All right.
Brilliant.
So it's not the prettiest, but we're here. And then if you tell me, I will just click the slides, okay?
Perfect.
Yeah.
All right. So quickly, you can see this is the farm I grew up on when I was a child. And that first slide there says nutrient density, which is a term we're talking about, which is to discuss this concept of nutrient variation. I founded the organization, the Bionutrient Food Association, in 2010 with the mission to increase quality in the food supply, as in nutritional value in food for all people. We can just go to the next slide. Previous slide. Basically, we started off as an educational organization working with growers around the US and then into other countries and other continents, helping farmers, growers of all scales, understand effectively how plants had evolved to grow for the past 420 million years before God invented fertilizer. And so the basic principle here is that nature evolved things to work, and that in many cases our struggles as farmers come from the fact that we are imposing what we think is correct and our will on nature, as opposed to, from a humble perspective, learning how to work with nature. These are some of the people here that are famous in the broader movement that have spoken at our conference. Recordings of every presentation from every conference are on our YouTube page. So we are, as an NGO, facilitating as open as possible education for all around the planet. Next slide. As we began to see that these principles of working with nature applied regardless of soil type, crop type, scale, climate zone, etc., we thought, look, if it's true that working with nature causes the plants to be healthier, the soil to improve, nutritional value to improve, farm viability to improve, this is the kind of thing we think should be brought to scale. And this is where we got the concept of a handheld spectrometer, that if we could provide people who buy food with the ability to assess the relative nutrient levels of the choices available to them on the shelf, they probably would choose the things that are best for themselves and their families and leave the things that are worst on the shelf. And that could then thereby apply an economic incentive to the supply chain to focus on nutrition as opposed to volume, which is currently how the market works. We started this project in 2017, building our first prototype meter. In 2018, built our first lab, tested our first couple of crops. In 2019, we built our second lab, got up to 6 crops that year, went down, started looking at the soil the crops grew in, overlaying management data about how those crops were grown. In 2020, we set up our third lab. Go to the next slide. In Europe and France, you can see there on the right-hand side the number of crops and the number of samples of each crop we collected that year. Each one of those green icons is a farm that was sending in samples of crop in triplicate with soil at multiple depths in triplicate with management data. So we're overlaying these dynamics to answer some basic questions about what the variation of nutrient levels is, what the causal factors are. At the bottom in the middle, you can see the metrics we were looking at in the soil. On the left, you can see the nutritional metrics we were assessing in the crops. This was our preliminary work. We were engaging to answer some basic questions, which were, how dramatic is nutrient variation in food? If it is dramatic, what seems to cause it? And then foundationally, is it possible to create a handheld consumer priced instrument which can assess nutrient variation? Next slide. Here on the left with sulfur, you can see it's we're looking at the variation here. So 8.41 milligrams per 100 grams of fresh weight was the level of sulfur we found that was the lowest in any carrot we sampled. 33.19 is the highest we found in any carrot we sampled. That's a 4x variation. You can see the sort of the fifths of the range. The red is 0 to 20, orange is 20 to 40, yellow is 40 to 60, etc. So it's a nice bell curve, but the peak of the curve is there, the 23rd percentile. So there's a 4x variation top to bottom in sulfur levels in carrots, but the vast majority of the samples had relatively low levels in relation to what's possible. Phosphorus is on the right, 11.7, 93.69. That's an 8x variation, not small, right? 800%. Again, peak of the curve there in the 27th percentile. Next slide. Antioxidants, these are health beneficial compounds people may be familiar with. 4.92 on the left, 195 on the right. That's a 40 4x variation. That's a 4,000% variation in nutrient levels. On the right, we have polyphenols. Polyphenols are those flavor compounds, aroma. Those are the things that correlate with anti-cancer, diabetes. Those are the sort of powerfully health beneficial nutrients that we are evolved to discern through our noses and tongues. 2.34, 4 to 9.75, that's a more than 20x variation, peak of the curve in the 7th percentile. You can see that's a bell curve, but really there's not, it peaks pretty early. So this is a variation, range of variations we found similar across the 25 different crops we looked at. So our governmental agencies oftentimes tell us that, if you look on the bag of carrots, it'll say X amount of vitamin D, X amount of zinc, etc., as though all carrots are uniform. In fact, they certainly are not. In fact, there is a dramatic nutrient variation in food. And this is part of what we're talking about, is there's some brilliant connections between soil health, carbon sequestration, ecosystem function, farm viability, nutrient levels, flavor, human health. And so again, our argument is if we can support people in being able to choose the food that's best for them, we can have very powerful positive impacts through a visceral economic driver, both on the climate, but also on our health status. Next slide. This goes to the question of what the causal factors were. On the left, we say by variety. So we see a number of different genetic varieties of carrot there. Effectively, you can plant a seed from a variety in one soil and have relatively high levels of nutrients, or in a different soil and have relatively low levels of nutrients. We see no connection between genetics and nutrient variation. That does not seem to be a dominant causal factor. On the right, these are USDA climate zones. So climate zones in the United States, the 48 contiguous United States, northeast, southeast, east, north, southwest, east, north, central, etc. You can plant a carrot seed in any soil type or climate zone and get a high nutrient level or low nutrient level. It does not seem to be caused by soil type or climate, that nutrient variation. Next slide. Point of purchase. We have on top there is, on the left is farm, the next one is store, the next one is garden, the next one is farmer's market. Some people think that basically where you buy your food connects to the nutrient levels in that food. What this data seems to show is that really is no direct connection between sample source and nutrient levels. In general, most stuff is not in that dark green or even green zone, wherever you source it from. And to the right, we have it's called by practice. On top is certified organic. Then we have people using cover crops, no-till, till, organic not certified. The next two are reference and none. That's basically grocery store, non-organic. Those are the ones in the middle that have the yellow. It's fatter in the yellow. Regenerative is the one after that. Effectively, what we see here is that all of the identifying labels and markers that we think we should, correlate to nutrition, like is it certified organic or is it local or is it no-till, again, does not correlate to nutrient variation. We find very, very few samples anywhere in the supply chain in that top 40th percentile of what's possible. And there don't seem to be correlations based on label like organic, et cetera. What we did find is those correlations seem to primarily be having to do with levels of life in the soil. And what that means is if you're an organic farmer, you can have high levels of life in the soil or low levels of life in the soil. And that correlates with whether your crops are highly nutritious or low nutritious. It does not correlate with organic certification. It correlates with actual system function, the microbiome function effectively. Next slide. Here we see the graphic of the handheld meter that we were able to manufacture, replicate, and distribute around the world, along with the app user interface on the app. I've got a version of that meter here. It's a fairly simple, rudimentary handheld spectrometer, but it's calibrated for 10 crops. It is, gives you statistically significant readings. For carrots, perhaps it'll give you only a reading for antioxidants. For zucchini, perhaps only for polyphenols. But this is published in the journal Nature. This works. It's a real thing. Handheld, consumer priced, flash of light nutrient meters are possible it is a viable scenario to envision people being able to go to their points of purchase, flash a light at the food itself, and with that spectroscopy metric, be able to discern the relative nutrient levels in food. Just a time check. How much time do I have before my Q&A section starts?
Sorry, we have for you until 10:30, but you still have 10 to 15 minutes for your slide if you want to, and afterwards we'll have some questions. So whatever works for you.
Okay. I can keep going. All right, next slide. All right, so subsequent to proving that nutrient variation is dramatic, that it seems to be caused by soil health, and that handheld consumer priced instrumentation is a viable scenario to, we think, disrupt agriculture globally. We began what we think is the real serious work of our research, which is to define nutrient density. It's one thing to say that the scale of variation in polyphenols is 20 to 1, or the scale of variation in phosphorus is 8 to 1. A much more complex question is, what is quality? How do you say that this carrot is in the 80th percentile of what a carrot could be, or the 20th percentile of what a carrot could be? Because effectively, that's how we envision buyers, consumers being able to engage with this framework, is an overall, unified number, 1 to 100. And so that project we began in 2021 with beef. We need to go crop by crop by crop. We decided to start with beef because it is the foodstuff that is produced on more acres than anything else on this planet. And if we're envisioning a situation where we want to use that economic incentive and visceral, human impulse to be healthier to positively affect ecosystem function and climate, we should be focusing on a foodstuff that is majorly affects the planet. Cucumbers are nice, but there's not that many hectares of land on the planet used to produce cucumbers. So the foundational thesis here is that if cows eat what they have evolved to eat, they are better for you than if cows eat what they're primarily fed now in the industrial agricultural system. Next slide. This sort of lays out our experimental design. I think we got samples from 4 continents for this project. The farmers were sending in the meat. They would send in a steak from 3 different animals. We'd look at over 100 different nutrients in each steak. So elements, enzymes, vitamins, fatty acids, polyphenols, terpenoids, alkaloids, a whole suite of different families of compounds. They would send in the manure for a microbiome assay. We look at over 200 different species of microbes in multiple kingdoms in the manure. We would look at the fodder, whether it was the mixed ration or the fresh green grass or the hay. We'd assess that biochemically for nutrient levels. We assessed the soil that fodder grew in. We asked the farmers a series of questions about the animals and how they were raised. And then finally, we did human health trials. So fed humans this beef and watched what the inflammation marker responses were, then fed them that beef, and then finally we fed them the fake meat. Impossible Burger is a branded synthetic beef substitute to watch and see what inflammation marker responses there were in the humans from eating that. And our thesis about how we define nutrient density is we take the biochemistry data from the steak and we give that to biochemists and say, tell us which samples look most optimally nutritious, which least nutritious, and scale everything in the middle. We take the microbiome data, give it to microbiologists and say, you tell us which animal you think was most well, least well, and everything, and scale the rest of the samples from your perspective as microbiologists. We give the agronomists the soil and the forage data and ask them to tell us which environmental conditions looked most and least optimal for the animals, et cetera. And finally give the nutritionists the human health data and say, to you, which inflammation marker responses looked best and worst. And then once we've given these data to each of the specialists in these fields and they've scaled it, then we would feed that back into a statistical analysis framework to look for biomarkers. And so this is the project we are just about complete with. We finally got our last bits of data back from the lab last week, literally in real time. This is happening right now. We're about to give now the complete data sets over to the standards board that we've developed from a series of global specialists in these fields. And we hope by the third quarter of this year to actually have our first ever definition of nutrient density in a crop. It'll be a preliminary definition. We've only spent a little over $1 million on this project. Certainly, we think that this is something that could be iterative and evolving and should really be done by national governments in serious labs with major funding. But as far as a first pass to attempt to develop a 1 to 100 scale of nutrient levels in food, we're not aware of anyone else on the planet doing this and are quite proud, actually, of what we've been able to accomplish. Our subsequent plans are now to, now that we've created this framework, to effectively replicate that for 20 more crops. And so our target is to start those 20 crops at the beginning of next year. We need to raise 25 million US to accomplish this project. It takes about 2 years to go from start to finish. And so our target is that by January 1st, 2028, we will have nutrient density defined, at least a preliminary definition of nutrient density in the 20 major, produced and consumed crops on this planet. Once that definition exists, then we can give those metrics to companies that build meters and offer them the opportunity to build instruments that can be used by consumers, used by wholesalers, retailers, packers, agronomists across the supply chain to begin this assessment process. Our vision is that the end game is that the camera in your phone will functionally be able to accomplish this. As we understand the physics, this can very likely be an app in your phone. And so by 2028, 2029, or thereabouts, people with a relatively up-to-date smartphone will be able to download an app and effectively go to their point of purchase, their market, their store, wherever they get their food, and literally with their phone flash a light at the choices on the shelf, get readings back in real time, be able to make that purchasing decision based on that information, if you so choose, and then simultaneously upload that information to social, to Facebook, to Instagram, to whatever communications framework you engage in to share with your friends, family, etc. That basic information about what is best available where in the supply chain. And so this is the effective strategy we've envisioned to allow people to make choices for themselves based on their own self-interest for themselves and their families that could be viscerally incentivizing a reversal of climate change and chronic disease. I think I'll stop there and take questions.
Thank you so much, Dan. I'm just gonna stop the sharing. So oh, that didn't work. Stop sharing so we can see you again. All right. Thank you so much, Dan. I'm just gonna stand kind of here. I'm very impressed with your story and also a little bit scared about the the variety in the food density. I will definitely look at the veggies differently now. 1 second before we're going into the questions. Good, the first question is already coming up. Even heel simpel, jullie hebben allemaal een microfoontje staan. Die kan je op klikken, dan gaat er een rood lampje branden en dan kan je wat zeggen. Wel even graag je hand opsteken en wachten tot je aan de beurt bent. En dan kunnen we starten inderdaad met de vragen. I just explained them quickly how the microphones work then. First, also you can, als je wil, kan je in het Nederlands je vraag stellen. Dan zal ik hem zo goed mogelijk vertalen. Maar het liefst in het Engels als het lukt natuurlijk. First question, I think it was here.
So thank you so much, Dan, for your wonderful presentation. And this is one part of the food system, of the nutrient density of the plants. But I'm wondering, have you also looked at the capability of the absorption of the nutrients that are in the food, depending of the state of the gut microbiome? Because if the gut microbiome is not functioning, how are you capable of taking up these nutrients, and also the role of, let's say, more traditional combinations of food. Like, so it's known that curcuma and pepper are making the absorption of certain nutrients more available, or the combination of polyphenols with olive oil and certain vegetables, so you can actually increase this absorption. And then to add to that, if your, let's say, your own terrain, your own soil of your microbiome is disturbed, is there a certain kind of order in which you should reintroduce these foods? For example, it's easier to have the ribeye to get the micronutrients than, let's say, maybe the kill, depending of your own microbiome. I know this is not part of your research, but it's something that's resonating with you, the things that you have been looking at?
Well, one moment before you answer, Dan, can you state your name and what you're doing quickly?
Sure. I'm Yunus, and I'm part of Cities for Better Health.
Cities for Better Health, thank you. Dan, please answer.
Yeah. Right. So we are effectively a very small NGO, and we've been able to do what we've been able to do. And yeah, we're coming from the agronomy side, from the simple assessment of the nutrients in the food side. There's a whole bunch of understandings in the nutrition world about bioavailability and gut flora and all that stuff. I propose that this conversation is one that should, be of the scale of import as, when I was young, it was the Human Genome Project that was being performed in the 1990s. And that was a global collaborative endeavor across many countries, many continents, many universities, because these are deep and important questions. So absolutely, the things you're bringing up are critical and relevant and important. Certainly, that is not what we've looked at. Simply, it's beyond our scale and capacity. But the vision here is that we're inspiring a global collaborative, research endeavor to look more deeply into these things. I think it sure looks like the function of your microbiome is contingent on your nutritional status. And so it's a chicken or egg. Sure, a lot of people's microbiomes are in poor shape, but if you don't have the core nutrients in your food for the microbes to exist, then how do you solve that issue? These are not the questions we've been looking at. Certainly, ideally, as part of a deeper collaborative conversation.
Thank you.
Thank you, Dan. I think we'll also touch upon it in the other talks today. All the way on top, please state your name and organization first, and then ask your question.
Oh. Hi, I'm Janne Hoek. I work for We Are the Regeneration, and we're also working on a big campaign with a lot of NGOs in the Netherlands on also healthy food for healthy people and how it's connected to agriculture. Thank you, Dan, for the presentation. Really insightful. And there's one thing you showed in the plots, that there was no real correlation between, for example, organic and nutrient density, but there was more correlation between the life in the soil and nutrient density. And we work also with We Are the Regeneration with farmers who are not always certified, so that's interesting. You really put the incentives on the practice instead of the certification. But I'm also wondering, there's a link between pesticides use and less healthy soils, and then also maybe less nutrient density in the food. And I also wonder if you look at that, controlling that specific thing, because I think it's also important to have the incentive not only on what you call it, but also what you do, and if there's a link between the two, so the use of pesticides and nutrient density in the food. Thanks.
The short answer is that it sure looks like the nutritional value of the food is directly correlated to the function of the microbiome of the plant. And if pesticides, herbicides, fungicides are foundationally accomplishing the task of killing microbes, then it should be fairly logical that it's effectively impossible to have high levels of nutrients while applying synthetic toxic chemistry. That being said, there's a cost-benefit analysis, and many practices that people engage in, like tillage and maintaining bare soil, are deeply destructive to microbiome, and a small amount of glyphosate added as a burn down to kill an amazing cover crop that then leaves an awesome residue in the soil can support sufficient microbiome to digest that glyphosate and have high levels of nutrients, higher levels of nutrients than, say, an organic crop. So as with all things, there's no simple black and white answer. It really seems to be the sum total of actions and their net effect on the level of microbiome being the strongest causal factor in nutrient levels. But what that basically means is if you have toxins present in the system, it's very difficult to get those high levels of nutrients. You can apply a small amount early on to a well-functioning microbiome that may have some small negative impact, but if you're really supporting the microbiome to a high degree, they'll digest it and those toxins will not be present at harvest. I hope that's not too
No, I
nuanced of an
understand,
answer.
but it's also important to see the incentive for the broader picture. So the way of farming and also what the toxins can be affecting in other ways, through air and through water and stuff. So I'm trying to see like how you can incentivize the broader picture and not only focus on nutrient density while looking at these factors as well. But
effectively, I mean, your cost of production goes down with the health of your plant. With the function of your microbiome, the cost of your production goes down. And so for whatever else is good or bad about it, it seems like the economic system of profit is a dominant force in today's day and age. And if it's true that cost of production goes down with system function from biological perspective, and system function from biological perspective is connected to nutrient density, then aligning that consumer choice for what's best for them actually directly correlates to ecological system function in a pretty direct way.
thanks.
So.
Yeah, thank you.
Thank you. Any other questions here in the front?
Good morning to you, Dan. I'm Evert
Morning.
Kerverzee of Mycocyclo. I have two questions, if I may ask. What is the correlation between the soil carbon sponge and nutrient density?
The soil what response? Soil carbon sponge. Yeah, well, functional carbon is directly connected to a well-functioning microbiome, so that would be fairly direct. What some people do is think that if they add lots of compost and then they have lots of organic matter, then therefore they've got a well-functioning system, and that's not true. Nature built carbon in soil through the liquid carbon pathway, through green leaves, making sugar and injecting it into the soil. And if you're building your soil carbon sponge in that way, you're going to have a really nice correlation between that and nutrient levels. But bringing in a bunch of compost in the back of a truck and dumping it onto your soil, and then therefore having lots of organic matter, that does not connect to nutrient levels. That's an important nuance. Second question?
Thank you. Second question is, what advice can you give for a country which is highly polluted?
To support the microbiome. Effectively, microbes, I say they've got magical powers, right? They can digest glyphosate, they can digest dioxin, they can digest PCBs, they can digest radioactive isotopes. The bacteria and the fungi really do have quite powerful capacities. And it seems like as we work with nature to create a dynamic where they're functioning more well, they will literally digest these toxins and effectively remove them from our environment. So ideally, we want to stop manufacturing and applying these things, but the solution, systemic solution, is to support the microbiome, and that's one of the foundational things they do is take these complex chemistry compounds and break them into their component parts, which are then no longer toxic.
Thank you. I quickly see another hand.
Hi, my name is Linda Buisman. I'm designing food forest and agroforestry systems. And I wonder if you have seen differences between annual crops and perennial crops, or do you expect to see in the future? Because I think perennial crops, they don't have to start over again every year to build up a relation with soil life, and the roots go deeper and they have more symbiosis with mycorrhizal fungi. Yeah, what have you seen so far, and what do you expect to see on that?
Yeah. Well, I think, again, the foundational dynamic seems to be the function of the microbiome. And to your point, you would think that perennials would have, as a baseline, a more well-functioning microbiome than an annual. But due to the fact that most of our soils are denuded, worn and weathered, and effectively not at an optimal level of function, you can put a perennial into a denuded soil and not have a high level of function. You can put an annual into a well-functioning soil and get a high level of function. So it's really difficult to have any black and whites in this conversation, except that the more well-functioning the microbiome is, the more well everything else seems to be. So you can't say organic is good, permaculture is bad, local is good, distant is bad, small is good, big is bad. Like it seems to be one of those things. I call it religion, where we want to sort of identify with, I'm a permaculturalist, I'm a no-tiller, I'm a locavore, you know, we're better. I mean, personally, I grew up on an organic farm and we knew we were better. And I know the permaculturalists know they're better, and the regenerative people are damn sure they're better. And my thought is, you know, this is why we have science. This is the purpose of science, is to have a dispassionate empirical conversation. And if we can agree that nutrition is the point of food, and we can use nutrients as a metric for what nutrition is, then we can begin to say, okay, this insight from permaculture is really valuable and important. This insight from biochemistry is really valuable and important. Let's integrate these insights from these different fields of study, not get too stuck in our silos, and see if we can find a collective higher ground upon which we can coalesce.
Thank you. There are a lot of hands still here in the front.
Morning, Dan. David Luijendijk. I'm a biodynamic grower. I have a trick question for you. You told that high density food is cheaper to produce because you have less input. So it should be cheaper in the stores, right? Yes.
I would say that it is less expensive to produce because nature is doing the majority of the work, because you've created a dynamic where she's able to function more well. So that the inherent capacity of the plant to realize its full potential is then therefore more realized. That was my experience when I was full-time farming until just a few years ago, was that I was able to not charge a premium for excellent quality food and make my living farming, working 20 hours a week, because simply nature was doing most of the work and my input costs were dramatically reduced.
So it could be cheaper.
I would propose that we should be able to outcompete the chemistry system,
right,
on price.
Right.
Absolutely. We should not need to charge premiums to people for superior quality food. We should be able to outcompete on price. Absolutely.
Thank you.
Is that a trick question?
The farmers always complain that they're not paid enough, but I think I get a reasonable amount of money for my pak choi or my haricot verts or whatever, and I find it stupid that we pay extra for good food. It should be cheaper. Either way, we should skip all the subsidies, etc., or we put down the cost in producing in pak soy, and it's possible. So why don't we do it?
It's indigenous cultures did this on continent scale for millennia, right? Indigenous cultures with no wheel, with no plow, with no beast of burden, with no inputs, were able to realize massive amounts of functional food production. So if they could do it for thousands of years on continent scale around the planet,
right.
The thing we should start with is humility. And just because we have a bunch of PhDs and a bunch of inputs and a bunch of machinery does not mean we're more superior or we know better.
Right.
In fact, what it really means is we're suckers, and we've been trained to be putting our money into a corporate system which is sucking our life force and perverting the environment, which is entirely counter to what we're trying to accomplish.
Right.
Yeah.
Thank you, Dan. I'm glad we're doing some activism here as well. I have time for one more question. I see a hand there.
Hi, Dan. I'm Cindy. I have a small food forest. What's, in your opinion, the best way to get the microbes back into the soil? If they're gone.
Yeah. This is the conversation, is what does nature need? And the foundational thing we need to understand is that we are here to be in service to and support of nature, not to impose our will on nature. And every piece of land has its own unique history, and it's, at this point we can say traumas and imbalances. And only when we are sensitive enough and broad-minded enough to be in relationship with that piece of land can we understand what it needs and then support it in being able to be more well. So that's a deep conversation. They generally say the biggest block is between the ears. If you're able to understand what land needs and provide it, you can have massive transformation that can occur in 2 months. Usually it takes many years for a farmer to achieve that response, primarily because they just don't understand what they're doing. They're operating from this reductionist, colonized sort of framework, and they aren't sort of more deeply in tune with the land. I do teach courses I call Principles of Biological Systems. I've been doing this for 17 years around the planet. The recordings of that are on our YouTube channel for free. Our thought is this is the kind of thing that needs to be in the hands of all land stewards on all continents of all scales, period, full stop. So it really is about a shift in understanding and going back to some of those more traditional ways of respect and humility in relationship to nature as a living sentient being, as opposed to a dominance and control paradigm.
Thank you so much, Dan, for your presentation and also answering all the questions. We're gonna move on to the next speaker. So thank you, and we'll disconnect, but I'm sure you'll talk to Susanna later.
Thank you very much.